So we're going to get started. So thank you everyone for joining our part 2 of our AI Open House series. Today we're going to talk specifically about facial recognition. And we know this is a very big topic, and we wanted to dedicate a specific session to this to give it its time and to make sure those questions and attention can be properly attended to for this. So I will ask the panelists to introduce themselves. Dr. Bland, I'll ask you to start because I have you up on the screen for everyone to see. If you could introduce yourself and kind of how you ended up on this panel and why you think you're chatting with us tonight.
Good evening. Well, yeah, good evening. I think it's you, isn't it? It's night time here in the UK. I'm Matt Bland. I am Chief Operating Officer for a charity called the Society of Evidence-Based Policing, which Chief Johnson is equivalent member of in Canada. And I was an associate professor at Cambridge University, and that's where I've done a little bit of research on live facial recognition, which I will tell you about tonight and attempt to make it explainable, because it's quite complicated, facial recognition when you get into it, but hopefully I'll be able to do it.
Amazing, thank you. I'll go to my panelists here. Peter, you want to start?
Yeah, thanks, Alison. Hi, everybody. So I'm Peter Lewis. I'm an associate professor at Ontario Tech University in Oshawa. I am a computer scientist by background, but now I run a research lab on trustworthy artificial intelligence. So I'm particularly interested in AI and what happens when AI meets society, and how do we kind of like talk about and think about that interface? What do we care about? So I spend a lot of time thinking about things like explainability, interpretability, bias. I'm going to talk a little bit about bias tonight because I guess people will have questions about that. Accessibility of AI systems and the impact of them on the world. Yeah.
Hi everyone, Chris O'Connor. I'm an associate professor of criminology at Ontario Tech University. I do a lot of different research in policing, but more recently I've been doing a lot on emerging technologies, disruptive technologies like facial recognition technology, as well as AI. My interest lies in public perceptions and how people think about facial recognition, AI, these sorts of things. And Andrea and I have been working on a project on facial recognition since 2020, about 5-6 years now. So we'll talk a bit about that tonight as well.
Yeah, and I'm Andrea Slane, and I'm a professor in the Legal Studies program at Ontario Tech University. My specialty has been in technology and privacy, technology and the various kinds of guardrails that we want to set up in order to be able to use technology and constrain some of the more rights-infringing potential uses. So that's been my interest since the early days of the internet, like an older person. But we've been working, as Chris said, on facial recognition in particular for the last 5 years, looking at both public perceptions and different kinds of governance models that could help make it that kind of rights protective use.
Amazing. So now that we've done the introduction, just to set the stage, because like we talked about, I think there's a learning curve, myself included, on what this technology is and how exactly it works, and kind of also demystifying it, but also you can only ask really good questions and challenge people when you know, and we're all on the same page with what this means. So I'm actually going to hand the mic over to Dr. Peter Lewis. I can get you to, do you want to come stand at the podium? Yeah, Dr. Bland, I'm gonna minimize you for a couple minutes while Dr. Peter Lewis chats. We can only have one Brit at a time. That's my rule. So I'll get you to. You can stand here,
Okay.
Peter, if you'd like.
You have my slides on?
Yep, they're in the room. Let me grab them.
I think this is Matt's.
Yours were there.
Yeah. Do you want to go to him first?
No. We'll just run them there. Here, I did one save. I will do just some quick housekeeping. Any questions, please feel free to use this QR code. If you need a hand on how to do that, we have some Barrie Police members in the audience here that can help you out. It's just an easier way for us to manage questions as they come through. And then that way I can see if there's multiple questions on one topic, for example, I can work to kind of conglomerate it into one. So please feel free to use that at any point throughout the evening. And once we kind of get through our discussion part and our Q&As, I will, here it is, got it. I'll keep an eye on that and then pose those questions to the panel, and then we'll have kind of a hot seat for the chief afterwards.
Okay, thanks, Madison. So I was asked to kick this off by just doing a little bit of an introduction into what AI is and how we might think about it. And I'm going to focus particularly on the question of bias, because this is one of the things that if you go and do a Google search and you look for facial recognition technologies and concerns, people will often first land on something around bias. So I want to talk about specifically what that is, how we measure it, and give you a bit of evidence. But first of all, you can barely survive a day without reading about AI in the news at the moment, right? And it's kind of strange for someone like me who they used to keep us in the basement because they thought we were the strange people, and now it's like we're get invited to do things like this. So one of the ways I like to think about what AI even is a definition from this woman here, Professor Margaret Bowden. She talked about it being computers that do the sorts of things that minds can do. I really like this definition. So you think about all the things that a human mind would normally be required to do, and it's this endeavor. Can we get computers to do those kinds of things, right? And you can look, the history of AI is actually pretty old. So John McCarthy in the 1950s, Alan Turing in the early part of the 20th century, we're all asking these kind of questions. So even though we've seen a lot of it very recently, it's by no means a new discipline. And in fact, I mean, even the ancient Greeks were kind of like speculating on building robots and stuff like this as well, right? If you go read some of that thing. I like to break down AI, roughly speaking, into 3 different kind of types. Right? This is quite helpful, I think. So we can think about deductive AI, which is problem solving. So you've probably heard about AI systems playing chess, for example, or something like this, or controlling a robot, right? This kind of logical reasoning thing. I like to think about that as deductive AI. Then we talk about predictive AI. This is the kind of big data, big patterns of data, and build training models and things like this in order to be able to make recommendations or predictions. And then more recently, we've seen a growth in generative AI, which is your ChatGPTs and your image generators and things like this, right? So this is creating new content. So really, I think we're here like in the zone of predictive AI because we're talking about sort of predicting, making recommendations from large amounts of data, right? We do actually, I thought the police in the room, so there are some sort of legal definitions. I'm not going to put up a Canadian legal definition here because we don't really have one, but and we have a lawyer in the room who can correct me anyway. So that's, but what I will say is I find this quite helpful. This is a widely adopted definition from the OECD, the Organization for Economic Cooperation and Development, that talks about an AI system being a machine-based system. So we know it's a machine that may have explicit objectives, might have some kind of difficult to get at, kind of implicit hidden objectives that were kind of like coded at design time. And it infers from input how to generate outputs, right? So it's kind of it's a machine that takes inputs and gives you outputs. There's no magic here, right? Even though they can be quite complex. Those outputs might be predictions, content, recommendations, or decisions, right? And these influence things, right? So these decisions influence the real world or virtual, the online world. And sometimes we talk about AI systems having what we might call autonomy, so the ability to be able to do things by themselves, right? So you kind of give them freedom to actually be able to impact the world. And other times you talk about AI systems not having that. So you talk about it just giving a recommendation to a human, and the human is responsible for making the decision. This is often quite an important distinction, especially as you start to think about the potential for harm from actions, right? I also wanted to just throw up a slide that talked about what is machine learning, because people often sort of use these words at the same time. Many people think about machine learning as a subfield of AI. And I just put a definition up again here to show you it's not super new as a concept. But the key thing here is that they're not explicitly programmed. So if you think about writing a computer program, normally you kind of do this, then do this, then do this, then do this, right? With machine learning, you don't do that. What you do is you write a program that then goes and looks at lots of data and identifies patterns and builds a model, and then it can do something, but you haven't programmed exactly how you do it. Right? The computer has learned how to do that thing for itself. And that's often where we end up with the challenge of things like interpretability and explainability, because we often don't know necessarily what it's learned and how it's actually working. We may be able to infer that by watching its behavior and testing it, but often we like to think about a black box. There's sort of things inside that we don't necessarily fully understand what it's done, and that comes from machine learning. So talking about facial rec technology, and I just did a bit of and I'm not an expert on this specific technology, I just want to put that out there straight away. But I did do a bit of a search to sort of see what's in the news around this at the moment and what are people talking about, right? And so what's out there. So, and I've put two very different examples here. So you can see on the left, we've got a case where facial recognition helped to reunite a kidnapped toddler with a family after 32 years. It was even able to look at the way in which the face had changed or potentially grown and then look for a match after that. So that's pretty impressive, I think, right? And on the other hand here, you've got something that happened just very recently where a grandmother in Tennessee was actually taken halfway across the US and put in jail in a different state. Off the back of a recommendation from a facial recognition system. Okay, and the reason for that is that, like any of these machine learning models, they are statistical in nature in the way that they work. They work on probabilities, and that means that because they work on probabilities, they're never 100%. Right? This is really important to understand. So that means that there will always be some errors of some kind. Right? And we have to decide whether we're comfortable with that, and we have to decide how we deal with that and what the consequences of that are, et cetera, et cetera. So one of the areas where these uncertainties and these probabilities can show up differently is in the way these systems can be biased. And so I did want to talk about this. It's also important to notice that bias and fairness, they're not exactly the same thing. People often like to use the words fairly interchangeably or kind of as opposite sides. Sometimes you want your system to be biased. If I'm building a breast cancer detection tool, I want it to be biased because it's more likely to be in women, right? So bias is not necessarily a bad thing. When bias leads to something that we consider to be unjust or unfair, then it can be problematic. And there's an important difference there. So really what we're looking at here is, when we talk about reducing bias, really we're talking about improving fairness and the absence of any prejudice or favoritism based on, for example, inherent characteristics, right? So this is kind of, I like to think about it more like, does it discriminate in a way that we would not normally be comfortable doing? Okay. All right, so technical part, right? I'm going to try and explain how we measure this, but I'm going to use hot dogs, okay? So ideally, we have something like this. My machine learning model, my AI system has said, I want to try and figure out if this is a hot dog or not, right? So if it correctly identifies a hot dog, then we call this a true positive. It's positively a hot dog and we got it correct, okay? So this labels it a hot dog and it's correct. If I get this, that's a pizza, right? But if the machine learning system has said it's a hot dog, then this is what we call a, if it said it's not a hot dog, it's correctly said that it's not a hot dog. So this is a true negative, right? It's not that. So it's got it correct again. So those are the two ways it can get it right. And then there are two ways you can get it wrong. So let's say if you have this, right? And it says, oh yeah, that's a hot dog, right? And it clearly is not a hot dog. It's a dog that looks like it anyway. This is what we call a false positive, right? So it said, yes, it says, we got it. We got a hot dog. We found one, right? But it wasn't, yeah? And then we have the opposite of that is a false negative. So this actually is a hot dog, but it didn't think it was, right? So those are the two different ways it can get it wrong. Does that make sense? So this is, and then just to prove that there is actually math behind this, that's how you calculate stuff. So two key indicators we're often interested in when we're measuring bias in situations like this are false positive rate. So how often does it get the false positives? How often do they show up, given that this thing's probabilistic? And a false negative rate. So how often does it miss things that it should have got, right? Okay. Now to map this onto things like using facial recognition, and this I've put a reference on here. This is from a paper that was published just earlier this month. So there are three possible ways that these systems could work. Let's say, for example, you're trying to identify a suspect or a missing person or something like this, right? So on the right-hand side, you've got the image you got on file of what this person's face looks like. Okay. And on the left, it's correctly identified that this is that person out of that group of four. Okay, so we got it right. Good job. This one here, it's actually identified someone else instead, and it's got a false positive for a different person that is nothing to do with the person that you had the image for. Okay, so that's an error it can make. And in this one, it couldn't identify the person at all, right? So there's nobody there. Fails to find a match, and so this potentially just leads to like a waste of time. Okay, I do want to just end by talking a little bit. I want to put some real kind of concrete detail onto this because there are studies that actually study, the level of bias in these kinds of systems. One particular one of this is from, and apologies for the huge busy slide, this is from a study that was done in the UK, maybe Matt will also be familiar with this, we'll talk about it, from October of last year. So there's a lot here, but what I'm going to just show you is that on the left-hand side of this, you've got the true positive rates. And on the right, you've got the false positive rates, okay? So what you can do is if you look at the all row, for example, you'll see that, so the T's are different thresholds. It's how certain you have to be before you say, yes, we've found a match, right? So you might want to be 90% certain, 85% certain, 70% certain. That's a policy decision. But if you look at this, for example, if you're looking at 90% certainty, you're going to get a true positive rate of almost 92%, right? You can decide if that's good enough. You can get a false positive rate if you lower your threshold because you want to try and be as inclusive as you can of something around like 32% false positives. Right? So that means you're 32% of the time you're identifying people who are not the person you're looking for. Right? Now, the interesting thing here from the bias points of view, and you probably already started to look at it, is you can see how those numbers vary as you move through different demographic groups. So I'll point a couple out. If you look at white males, and look to the far right column there, you'll see that the threshold is 0.7, which you might choose to use. The false positive rate is 8.4%. Thanks, Madison. Yeah, 8.4%. False positive rate for white men. But if you look a little bit higher to Asian females, that rises to 48%. Okay, and this is with one specific piece of technology. It may not be the one you're considering here, I have no idea, but this is a specific piece of technology that was evaluated last year. So, like I said, bias is it's a property we can measure. Whether this matters is what I think you need to decide, right? So what are the consequences of having this kind of uncertainty in a system? Does that matter? Is there harm from this or not, right? It could be if you're trying to find a missing person and you get it wrong 3 times, well, nobody minds, right? Because you're just trying to find them. But if you're using it in other purposes, you might end up, for example, bringing a grandmother halfway across the country, right? So, so my kind of take home really from this is you're not going to be able to just remove bias. You're not going to be able to go by a system that is bias free. That is not the way this works. You can try and reduce it in certain ways, but I think I would encourage a conversation that you have to be around what are the consequences of choosing to use this or not using this, and the consequences of the bias that are in the models that you actually have. I think hopefully that's a good starting point.
Absolutely. So like I said, we'll do questions through Mentimeter, so I'll give everybody just a quick second while I transition over in case you do have some questions and you want to pop that into the app so that it's still fresh in our mind, and then I will pose those afterwards. Thank you, Peter. And Matt, I'm going to bring you up, if that's okay with you.
Of course, yeah.
And there it is. I lost my mouse. So I will, okay. There it is. I will let you see your screen. Okay.
Oh, hello. Okay, there we go.
Is that good?
Yeah, like you've done it up because I didn't make it look like that.
Yes, no, that wasn't me either. That was our communications team because they're the best. So.
Fantastic.
And then you let me know when to switch things.
Okay, yeah, brilliant. Thank you very much. So obviously it's the end of the day here in the UK, and my wife's in bed. I just texted her saying, I'm actually speaking to a community group, which I thought I was going to be talking to police officers. So I prepared slides for police officers. So now I'm going to try to adapt that to members of the community, which is a good thing, because I think people who do research like I do should be able to explain it to people who aren't from the sector. Otherwise, it's fairly meaningless. And I'm really pleased with that Peter went first, because he's explained a lot of the groundwork there around facial recognition. I'll talk to you a bit about this one very small study that we did in this one high street, one sort of main street in the east of England, It's it's a really small scale experiment, but it was really hard to do because we were trying to test something you can't really do in the real world, and I'll try to explain that as I go along. What I should say up front is this is a variation of facial recognition that's called live facial recognition. So this is deployed in live time, so that there are different types of retrospective facial recognition, for example, would be where police take CCTV and then they put the facial recognition software over it, and they sort of review what happened in the past. In live facial recognition, they are deploying usually vans, so 2 vans which will have 2 cameras on pointing in different directions. They'll go out into a location, usually where there's big crowds, and they will scan the public as they walk past in live time. Inside the vans, you've got computer terminals and operators on those terminals who are watching the feeds from those cameras, and they can see the software scanning the faces as they go. It's a very minority report. It's very future tech. In these instances, what they do in the UK is members of the public can go in the van and have a look at what's going on, and quite often they do because they're very interested in technology. It's a really good sort of form of engaging with the community. But you can see, so there's almost like literally an alarm in the van. So when the software identifies somebody, the alarm will go off, and the officers in the van will communicate with officers who are out on the ground around the van to go and have a go if they're comfortable that it is that person. So they'll be seeing the image that the computer is matched against. They will then ask the officers to go and take that person aside, and effectively they're trying to identify that person. So nobody's being arrested, nobody's being sort of thrown to the ground at that point. It's usually a polite interaction, asking them to come back to the van and identify themselves and establish that it's the person they thought they were looking for. Obviously, if the person starts to run away or they pull a weapon, then things go south quite quickly. But that tends to not be the interaction. This has been a tool that has been, well, it's quite far down the road in the UK. The government's invested quite a lot of money in vans for police forces to use. Mostly it started in London, a little bit in Wales, and there were some legal challenges when people were stopped and they were effectively not the people, they were misidentified. So the alarm had gone off when the officer stopped them. This wasn't the person who they thought it was. And there can be a whole array of reasons for that. Peter's already described some of them. You know, that the algorithm is biased, or it might be that the reference image, the image that the computer is looking at to match against, is actually a bad quality image. They're often not the best quality images. So there's more than one reason that they can be wrong. But there's a really important characteristic about these systems that you need to understand. They kind of have a dial that you can turn, and Peter explained it as, this is like the software is scanning the face and then doing this faster than a human ever could, looking at these databases of tens of thousands of images and instantaneously sort of placing a bet against each of those images of who does this person match. And what the dial does is sets the threshold at which the alarm goes off. So if the operators decide, 50% and above, if that's a match, then the alarm will go off. And what police forces can do is turn that dial up and down. They won't do that in the van. At any given moment in time, this will be a policy decision. Usually, the whole agency will decide what they're going to do. So, complicating that is there are different types of software. So you have companies like NEC who put some software out. You'll have other facial recognition software is available, and they're all different. So they possibly 50% score on one system doesn't mean the same as 50% on another system, and they'll never tell us if they're the same or different because they're all private businesses and they don't want to share their commercial secrets. So we can never tell that. So This study was all about saying, okay, well, for this particular tool that Essex were using, the police force that we were working with, what's happening in terms of bias or equity, as we call it, across different demographics. So Peter really eloquently described the true positives and the true negative concept here. I'm just going to confuse you more by using two different words for that: sensitivity and specificity. But let me just explain that. Sensitivity is how good is the facial recognition at catching the people it's supposed to catch. So if a bad guy walks past the camera and we have got them on the watch list, how good is the system at catching that person? And specificity is how good is it at leaving innocent people alone? So, you know, if just John Smith walks past the camera and we're not looking for them, does it let them go, or is it picking them up? So we're looking at it from both those angles, and we are trying to assess, look, does it do this differently across different age groups, different sexes, and different ethnicities? Now, just ignore the last question on my list there around what they call occlusions. This is things blocking the face. So that, you know, what this system works by mapping the face. Obviously, you wear a face mask, you're wearing glasses or a hat, it can map less of it. So there's a whole branch of this study where we sort of compared the effects of when people were doing that or not, but I won't go into that tonight. So what we did, just to try and make this a bit more real for you, is we had these two vans set up in the live deployment. This is the main street, if you like, in Chelmsford City in Essex. And you can see there the red arrows are the directions that the cameras are pointing approximately from those two vans. So they're parked right next to each other in a pedestrianised area, main shopping district. And then we've got 5 bases, the green circles that you can see around that map, where we put actors. So we actually hired 200, and 188 showed up. So these were all extras. So they've done things like Harry Potter movies and all sorts. The reason we did that was when you test facial recognition, to know how good it is at picking up the people it should pick up, you need to know that they're there. Now, if you do this in a real world scenario, and John Smith is on your watch list, but he walks past the camera and you don't pick him up, you won't know that unless an officer has seen him and identified him, which is pretty rare in a crowd situation. You certainly can't do that at scale. So what we've done is effectively we've rigged the game because we know who is there. So if you go to the next slide, Alison, this will hopefully make a bit more sense. We've made these poor souls walk up and down all day with these numbers strapped to them. So we split them up into 5 groups, and we sent 1 to each of the bases, and then we basically yelled go, and then they walked and traipsed back and forth for about 6 hours. And you can see the umbrellas are up there. This was done in February. It was freezing cold, driving rain. They were soaked. It was horrible. You can see that our actors are the ones with the numbers on. And there are other people mixed in who weren't part of the experiment. They were just out shopping that day, so they're not involved in the experiment at all. But of course, what we knew from those actors, we knew their ethnicity, we knew their age, we knew their sex, because we had recorded all of that information. And the crucial thing is we knew they were there. So if the camera picked them up, that's great. We know that's true positive. But if it didn't, we know it's missing them, and that's a really important part of this study that we did, that is not traditionally available to police forces who are out there working with these types of this type of technology in a live environment. What we also wanted to do was, now this is when I get to my technical slides, so I apologise. Don't worry about the numbers. I'm going to talk around the numbers, and you can have a look through these slower time if you're interested. Because we made people go up and down all day, we got them going past the camera 50, 60 times. And what we were able to do is then sort of build up this profile of people. It's the same people going back and forth, so it's not perfect, but it's a reasonable estimation. And what we then did afterwards was just worked out which ones the camera could see, and then we sort of put them in a blender and shook them up and said, okay, for each 5-minute segment in the day, this person in this segment will be looking for you, we'll put you on the watch list, and in this segment we'll say you're going to be a member of the public. We're not going to be looking for you. So if the camera picks you up, we know that that is picking up an innocent person when we didn't want them. So you've got these actors playing the roles of bad person, innocent person throughout the day multiple times. And so that's how we've rigged the game, if you like, to see if we can detect any biases in the system. So if you go to the next one, please, Madison. As Peter talked about, what you've got going on in this type of experiment is a comparison between what the machine is predicting, is this a person who's on the watch list, and then what actually happens. And in this case, we know, because we know the people were there, if it doesn't pick them up, we know that is a false negative. Okay, so it's saying the person is not there, but we knew they were there, so we can start to pull that apart. So if you go to the next one, please. Right, now we go to the horrible graphs. Now I will try to explain this the best I can. Okay, so the vertical line there is how good it is at picking up the people you wanted to pick up. So at the top of that line, the vertical line, is 100. That's getting 100% of the people. If it's up there, it's getting 100% of the people that you want it to pick up. Now, the line going horizontally on this graph is the dial. So it's the percentage accuracy, the percentage at which the alarm goes off. So at the bottom of that horizontal line, you've got 20% accuracy. If you turn the dial down there, it will get all the way up to almost 100%. It will get mostly everybody that it's supposed to get. And of course, we knew they were there. But obviously, as you turn that dial up, as you would expect, the percentage that you're going to get accurately starts to diminish. So almost to the point where you turn it up to 90% accurate, and it's not going to pick anybody up whatsoever. So the question is, what's acceptable? At what point are you happy to run with that dial? Where are you happy to play it? Obviously, if I tell you, I usually with presentations like that, ask people to guess where they actually do set it. They in S6, just blindly, they were operating it at 55. So they're getting just over 6 out of 10 people that they could have been getting, but they would never know that in a real world scenario because you don't know what you don't know. We go to the next one for me, please. Oh, that's okay. If you go to the next one, just go to the next one, and I'll stick with that one because there's far too many numbers on that side. And this, based on what we've just been talking about with that graph, you're looking here at two exactly the same graphs, but on the left-hand side is breaking it down by ethnicity, so each line is a different ethnicity, and on the right-hand side you've got sex. So let's just talk about these two graphs because these are where it really gets important, I think. Same trends in both. The higher you turn the dial in terms of it, setting the threshold higher for the alarm to go off, the less accurate they get at picking people up. But what you'll notice on the left-hand side is that there's quite a bit of difference between, say, the green line, which is this kind of catch-all of other ethnicities that are not white, black, or Asian, and crucially, the red line, which is black, black people going past the camera. So what this is saying is that at the threshold they're operating at, you're actually, if you're a black person, 30% more likely to be correctly identified than if you're any other ethnicity. So that's got some implications to it. I think traditionally the public concern has been that it would falsely identify people in a skewed way. What we're showing here is actually it's correctly identifying people in a skewed way. So yes, it's picking up black people going past the camera more than it is, say, white people. What that technically do is, if you're a white subject who the police are looking for, you've got more chance of getting past the camera. So when you look at it from that angle, that's not so hot, But what you can do is minimise that risk by turning down the threshold. That's what this study shows. Mm-hmm. On the right hand side, So the same is true there for men over women. Almost at every threshold, the system is better by some magnitude at picking up men correctly as they go past the camera. What we also found was that with the people it shouldn't be picking up, it almost never does that. And I think a lot of the criticism and scrutiny of facial recognition has been these misidentifications of innocent people, and that's probably, I'm speculating, led to quite a lot of training of the models in that respect. So they are very good at this kind of not picking up people they shouldn't. But that is still really the focal point of the public debate and the media debate around facial recognition, is this stopping of innocent people. And what we haven't really talked about much is actually how accurate is it at getting the people it should be getting. So that's the kind of next step. What I would say with all of this is one study on one rainy day in one town in one part of England with 188 people on one algorithm. So this is kind of the first piece of a jigsaw puzzle that needs to be sort of built out for every iteration of facial recognition tool that we've got. And what we would ideally be doing, and every researcher in the world will say this, is doing this study 100 more times to see if these patterns stand up when you keep replicating. But this has got some interest here, and what it's starting to do is sort of shape out a way that we think about how we test these tools, because they have important implications for how we're policing communities. So I think that's me. I think that's the last slide, Madison, isn't it?
Yeah. Thank you.
Yeah.
Matt, I want to pose a question, and please tell me if I've interpreted this wrong. So I'm also along on the ride with the audience of wrapping our heads around this. So, from the findings, it shows that it, traditionally maybe wasn't very good at picking up a certain group, so such as racialized people. And then now what we've done is tried to correct that, and in this example, overcorrected it so it got really good at identifying racialized people. And then now we're leading to kind of over-representation on that side.
Well, I can't say that definitively.
Okay.
I mean, if that were true, it might look like this.
Okay.
So I think it's plausible, but they'll never tell us how they train their algorithm. So we won't know if they trained it on more.
They overtrained it.
Too overcommon. So no, we won't. You can speculate that, but because it's a commercial, there's millions of pounds, millions of dollars, wrapped up in the tech. They'll never actually disclose it, so people can't steal it.
Right.
So that's a challenge when you try and use this in a way and bring the public with you. As Peter said, this is called like a black box technology. That's really tricky, but you'll hear some. I mean, these tools aren't magic, but they are incredibly powerful. I mean, I've seen examples where it will pick up a subject through their reflection on a shop window. So it can't see their face, but it can see it in the reflection, and it correctly identify the person because we knew they were there. And officers will tell you stories of it picking up, a sex offender walking down the road with a child, and those stories are incredibly. But officers generally can't do that. It would be exceptional for them to be able to, exceptionally lucky perhaps for them to be able to replicate that at scale. So with all of these things, there's a trade-off between the upsides and the downsides.
Absolutely. Peter, I know you wanted to jump in.
I was just going to jump in. Thank you, Matt. That was really interesting to see these figures. I mean, I just, in response to what you were asking, Madison, I wonder if it seems to me from combining the table that I showed and then these charts that you showed, Matt, that there was a higher false positive rate with racialized people, and there's a higher true positive rate with, in this case, black people, and so that would suggest there's just a higher rate of selecting the positive class for darker skinned people in general, whether that's correct or not.
Absolutely. All right, thank you, Matt. I'm going to minimize you for a sec, just so we can put the slides up. But if you do want to jump in on any of the questions, let me know. But I also understand if you just want to go to bed. We also understand that as well. It's when you're up anyways, right? Like you're up anyways. Okay, awesome. So I'm going to start this slideshow up. So thank you for that. And like I said, I'll keep you unmuted. So if you want to pop in, just give me a wave because I can see you on here. Where's my mouse? Okay, there it is. Awesome. Okay, so lots to think about. And I know there's some questions coming in on the Mentimeter, and thank you for that. I think it's very interesting to talk about the black box and the proprietary nature of these things. So I'm actually going to go off script because I'm just very curious about this. From a legal perspective, Andrea, is are companies or corporations in Canada regulated in terms of transparency or sharing any of this? So what if the chief wanted to purchase this technology and he asked these questions and they say, no, I don't want to tell you?
So that's a very interesting question. There's nothing compelling the company to expose its commercial secrets, like its trade secrets.
Yeah.
But in a contract, you can require all sorts of things because that's an actual negotiation that goes on. I think there's been a lot of pressure to say there has to be some sort of auditability. I mean, I think that's what you're getting. So whether or not it's actually exposing somebody's valuable commercial property, basically, versus being able to do certain kinds of testing to verify things like, what are the different levels of accuracy or sensitivity and all those sorts of things. Like, I think those are somewhat different things.
Yeah.
So I don't think the black box has to be completely, obscure. It can be something that can be, certain parts of it can be opened up without losing what the company values.
Right.
And that can be negotiated.
Right, and so
Right.
I think that's really important for not only our chief of police and deputy, who are both sitting in the room, but chiefs across Ontario and Canada, they also need to be informed enough to ask these questions to the vendors and put that in their contracts.
And it would be possible for the government to mandate that. Like, that could be something that, because, policing is a public service, right? Like, it's something that certainly there could be a statute that was created to require certain kinds of disclosures before they can contract with a police service.
Gotcha.
But they haven't done that yet.
Right,
Yeah.
so something for maybe us as communities and police services and researchers to advocate for and come together on. Yeah,
Can I ask Andrew?
yeah.
Do you need to explain that in court, like how the company identify people?
So that raises a whole other question.
We like to open cans of worms.
Because I think, so one of the things that's interesting, I think, about this technology, and I should say, like, right away, that in Canada, we don't use live facial recognition on the street like that. That's not what's being done. There may be some desire to do some version of that, but it's not something that's currently being done. But I think a lot of times the tool is being used as an investigative lead.
Yep.
And so it doesn't end up being the thing that triggers somebody being arrested or evidence being gathered. So it doesn't end up in court in the way that it might in order to challenge it. So that's one of the problems with it, because it's like it's before that point.
Right.
So, so we need to sort of manage what that means. If it means that it's like a tip, like a tip that comes in and says, you might want to look at this person more closely, or you might want to ask some more questions or look around, that's a different point in the investigation, and it doesn't add into the case that ends up in a trial.
Right.
So I think that's another kind of ethical kind of question too, as well as a legal question. Yeah.
And I will clarify right now, Very Please is not using facial recognition. We do not use facial recognition technology, but this is really the point of these conversations, right? There's some questions that have come up with, okay, well, as a community, what's our comfort level in terms of that threshold and how far we turn that dial? And I think that shouldn't be up to the Barrie Police to decide on their own. I think that is really meant to be a community conversation. And while these are seen as kind of like the starting points, we'll talk about a little bit at the end how we're going to continue to keep in contact and how we're going to continue to kind of go back and forth on that and hear where people's comfort levels are. But please know that this is, like I said, as a service, we're also on this learning journey. And ideally, as a community, we're deciding what we're comfortable with. It would be great to see on higher levels in terms of governments and policies kind of also doing that work. But For now, we're gonna take it from here and see where it goes. And I did want to ask Chris and Andrea, you guys have done a lot of work on facial recognition and perceptions of it. And from your work and your research, can you explain to me some of the biggest concerns that you're hearing from communities about the use of this kind of technology?
Yeah, I can talk about that. Yeah, we did a survey of the Greater Toronto Area. We surveyed about 1,000 people. And so one of the first questions we asked people was like, what's the first thing that comes to mind when you think about facial recognition? So that's sort of their gut feeling, I would say, right? So, 50% of people hold sort of dystopian or negative views about it. That's their initial gut reaction. So things like Minority Report, RoboCop gets mentioned, that sort of stuff. 1984, Big Brother, Black Mirror, these sorts of TV shows, right? So that's the initial concern, but there was also 30% of people had positive feelings about it. The ability to identify suspects, criminals, that sort of thing. I have lots of stats too, but I'll try to talk about general stuff. So I'll talk about this in sort of three groups of people. People that are sort of over 80% of people feel good about or feel comfortable with FRT or facial recognition being used for things like identifying victims of child sexual abuse, trafficked individuals, missing persons, human remains. So anything with victims, that sort of thing, people don't seem to have a whole lot of problem with that. The next group would be people between 50% and 80% are comfortable with some of these uses, and these tend to be around identifying people who have committed crime or they're suspects in a crime. So it could be, scanning a suspect's image against a mugshot database. People are pretty comfortable with that, or the majority of people were comfortable with that. And then the public are much less supportive of things as it becomes more vague. Or maybe if it's being perceived as being used against them. So if you're going to use FRT at a traffic stop, people did not like that so much. I think only 30% of people were comfortable with it being used for that. And vague things like if you're going to use it at a political protest, very little support. So it had to be concrete. It had to have some sort of concrete application of the technology for them to be comfortable with it. So the farther away you got from that, the less comfortable people were.
So ideally, the police are very concrete in their use cases and transparent about when they're using it,
Yeah.
right? And that will then, I won't say negate a lot of the concerns, but I think that increases the level of comfort in terms of using this kind of technology. Because like I said, it's very hard to question what we don't know and what we're not aware of. And so the more aware and the more informed we are as a public, I think that's when we're able to look at these things with a little bit more confidence. So talking about the bias and the privacy, these are actually some questions that we got in our pre-event survey and even through Mentimeter kind of last time. So like I said, we're collecting all this information, and although we won't be able to answer every single question tonight, I'll work with our comms team on, whether it be interviewing with the chief or kind of reconvening this panel virtually to chat a little bit more, but we will aim to answer as many of these questions for you as we can at later times. I wanted to ask about, we talked about technology in your bias in a tech sense, right? Your false positives, all of those pieces. Chris and Andrea, again, in your research, are you able to kind of talk about the impact of bias and the social implication of that?
Yeah, I can say something sort of about that, but it's not directly from the research, I'd say. It's just sort of more like, again, kind of positioning it in Canada, where we have had a history of thinking about the problems with, say, stopping people of color more often than not people of color. So the sort of carding street checks, those sorts of things, so that even just pulling people aside and saying, are you the person that we think you are, is actually more loaded in Canada. So like this sort of experiment that they did, I think would not fly quite the same way in Canada. We also have some guidance that we get from courts and also from our privacy commissioners about privacy in public. So that the sort of fear about being identified when you're doing something that you're meant to be sort of anonymous to do, sort of just go out shopping on a main street. You don't expect to have like your name pop up over your head, right? So I think that is an additional cultural kind of sensitivity to be concerned about. So the thresholds, again, might be different in Canada than they might be in the UK. And sort of meeting that and sort of, so it's I think the distinction between bias and fairness, I thought was an interesting one on some level, because fairness, I think, is a much broader term, right? Like that sort of captures absolutely everybody, like the sort of idea of like, should I be identifiable when I'm walking down the street, versus, and what gets done with that information, versus, are certain people being targeted more often than others, which is the bias question, right?
Right, absolutely. And I really liked the community member who put this question in, of course, anonymous, I don't know who, but the idea of like misidentification trauma. And I think that's deeply rooted in racial trauma and all of those pieces and historical contacts with police, right? So these are things we need to remember and consider. Peter, from a technical perspective, I'm gonna ask the question, I know the answer. Can we ever have 100% accuracy and zero bias?
Nope.
Okay. Is there an industry standard or kind of like a what you've heard as like a socially acceptable level of false positives and those kind of guidelines maybe that police can use as starting points?
I'm not aware of any industry standards on this. That doesn't mean they don't exist, but that's not something that I could speak to or am aware of.
Okay.
I think if you talk about socially acceptable levels of this, so maybe I'll develop a little bit from what Andrea was saying as well, because this distinction. So bias is a technical measure, right, that I can use. It's a statistic. It doesn't carry any kind of weight in terms of like what matters or what doesn't matter or our values. It's just a number, right? And bias can be good, bias can be bad, bias can be horrific. What we need to concern ourselves with is not what the right number is, but what are the consequences of making the wrong decision.
Right.
And in some cases, those consequences might be pretty negligible and bearable, and most people will be fine, right? And in other cases, they might be harmful.
Right.
And in some cases, they might be kind of systemically harmful, right?
Absolutely.
If you start, because a lot of the way to think about this is, we're also talking about automated systems that operate at scale. So it's not like there's a 10% probability of this thing happening once. It's like, if you're doing this all the time, that's like a constant 10% kind of error rate, right, all the time, So that means that people at that rate will be misidentified or not identified or something like this. So it's not like there's a probability that it happens and hopefully it doesn't. It's like, if you run this stuff at scale, like it is happening at that rate.
Right.
And that means that as a community, you've got to decide whether that's okay or not, right? So I think I would really encourage this, the conversation to be about a lot more, maybe speaking to this, a lot more concrete about, in this particular use case, this error rate means this for these people, and not like, what's the right number?
And I think that a key part of that is partnership, right? Looking at experts kind of on the tech side, but then tying in experts on kind of that social science piece and kind of the social implications of what kind of these technology choices mean.
Yeah.
And trying to find a way to make that make sense.
And we're very comfortable with different acceptable error rates in different situations all the time, right? For different kinds of technologies, right? Like, what's an acceptable failure rate for an airplane? Like, it's not 1%, right? You know what I mean? So we're used to thinking like this, right? But it's also not zero.
Right.
So somehow we kind of like land at something and then we do best effort, right? But we do land at something that we're happy to kind of accept as a risk when we do that. And that's why I think the community conversations are so important. But it's not a general, what's an acceptable threshold for facial rec technology?
Right.
It's like, what's an acceptable threshold in this specific use case?
Right.
You know?
Chris?
Well, I was just going to say, yeah, and including the community in those conversations, right? I think a lot of the times that doesn't get done. We don't have these great events like this, right, where you're actually reaching out to the community and seeing what they think. So more of that needs to be done so that the public can actually understand these thresholds and these sorts of things.
We talked a lot about fairness. So I guess this can go to the panel. I had it specifically for Andrea, but I've been picking on her a lot, so I may go broadly. So how can police implement these technologies to ensure fairness? what kind of checks and balances need to be put in place?
Do you want to go? No, I could go.
Anyone?
I'll start.
You want- okay.
I'll throw it back to everybody else too. So, I mean, I think that we are developing certain kinds of norms around, because right now there isn't a legislative structure that's going to tell police services what they have to do. So everybody's having to come up with their own version of how they're going to govern their use of different technologies, whether it's this one or other ones. And we're starting to see certain kinds of mechanisms that are helping to ensure that mistakes don't happen in a way that's really harmful. So, you know, one of the things is definitely human in the loop, right? Like to make sure that it's humans that are making decisions, not machines, right? Like, because if you allow the machines to say this person is that person for sure, as we know, it's not going to be accurate X number of times, percentage of the time, all that sort of thing. So it has to be human verified. Everything has to be human verified. There have to be limited uses, like limitations are important, right? Like so that if like that you're willing to accept that risk in that kind of context. There's also the sense that, like, you know, some of the technologies are really just, they're like image matching, right? Like so that you can have a way in which you're really only retaining data for the matches. And nobody, so then the name isn't popping up over your head because the people are not being actually, and no information about that person is being retained. Because part of the problem, you're going to be tracked, right? Like that every person can be tracked, right? And if you build the technology in a way that it will not retain data on people who are not a hit from your hit list, you still need to put a lot more protections in place for the people who do show up as hits and how you're going to verify that. But you also need to like make sure that it's not over capturing and trackability of like a lot more people, I think is something that's very concerning and that you can constrain with rules. Yeah.
Any other thoughts?
I can add to that a little bit, I guess. I mean, transparency for me would be key. You know, what is the procedure? What are we using it for? Can the technology be independently audited for bias? You know, what happens when you get it wrong? Are we going to report that back to the community? These sorts of things. Mm-hmm. So really just collecting data, collecting evidence, doing the research, and then learning from that, and improving how you roll that out.
Yes, and so that's a big thing. We mentioned kind of there's no legislation guiding the use of this quite yet. And I think rightfully so, as a community, we're going, yikes. So who, you know, a question that comes up is like, who watches the watchers? So who's the chief's boss? And who does he have to answer to for, you know, some of this misidentification, or who has the power to kind of start the regulation on these pieces and oversee some of this stuff and correct things if misused or it's going way too far out of an acceptable range?
Technically, it's the Police Service Board, and that's a very important function of the police service, and I think they're probably under-equipped to deal with some of the things that are coming up. They need to learn a lot more about how that role will play out in this new technological environment, so they need a lot more support. That's another part of our project that we aim to do to sort of bolster the capability of the civilian boards to sort of do that oversight function. And then also, as Chris was saying, like to provide means of community feedback that's like ongoing. It's not like a one-time, like, you know, okay, we're going to deploy this, so let's get your feedback today, but rather a regular kind of check-in ability to sort of make sure that, you know, that people stay informed and that, you know, the accountability is consequently there.
Gotcha.
Yeah.
So I will say, of course, as every police service in Ontario and Canada has, we do have a police services board that oversees. The chief meets with them monthly. There's public meetings, and our community can connect with them and get in contact. And again, when we say if, you know, we have to ask the structures in place to hold people accountable, so that is absolutely an avenue for community members. And then as we continue to update you, like ideally this is going to be a place of transparency, but just putting that out to the community, right? There's always the police service board that oversees the chief, oversees the service, and that's going to be kind of the person or the group that would, you know, course correct some of this behavior if it becomes unacceptable. And that's to anybody within and outside of the Barrie community, right? Your various police services will have police services boards, and that's probably a great way to start asking more of your service.
Leadership too, though.
Yep.
I mean, like the chief is the one who has to bring it to the board, really,
Yep.
to their attention,
Yep.
right? Like, so I think that leadership makes a really big difference.
Absolutely.
Yeah.
I wanted to pose a couple questions to the chief. As he's diligently making notes there and trying to, don't worry, chief, this is recorded, you can watch it again. So there's some questions that were pre-asked on the survey that's been running, as well as some questions that we're getting live time. So just out of fairness, I'll do the questions that have been asked already. Chief, I'll ask you to be brief with your responses, if you can, just so we can get as many in. And then, like I said, we'll continue to connect through our website and find ways for the chief to kind of get these questions out. Can you come up here, because we have to share mic. Okay. So in Barrie, what circumstances is BPS considering using facial recognition?
Thank you. So I will be brief, and I appreciate, because I know there's going to be a ton of questions, and I do invite them. So the low-hanging fruit from a public safety service and from the research, which I did see on the Canadian Association of Police Governance, that presentation, and the research should inform our practice, and that was, so when we look at vulnerable populations, missing children, victims in immediate need of assistance for identification purposes. And we can debate it all day long, but we're here to help, and that would be one of our primary, is to help people, is to reduce victimization. And I have an elderly mother, and let's argue it, but we're going to argue it because I think there's legitimacy on the side of police if we want to use it to help find those victims that need assistance. Is that fair? Oh, and then to limitations, and I think that was, and I'll make this quick, to constrain, we're not looking, this is not a, I think technology can be used effectively, but it can also be misused effectively, and that's not what we're after either. So if we were looking at a imminent threat to public safety, and I mean imminent in a large, in a very concerning manner, where it's what we consider high harm. Folks, we have traditional methods, and I appreciate there's going to be some who want it on the other end of the spectrum. Minor offenses, I don't want to live in 1984, George Orwell nightmare. I like the movie Minority Report. We don't have precogs. I struggle with that. We're not looking to do that at any stretch of the imagination. I think responsible, auditable use is what the community would expect of a public safety service, and that is if we have a known, and these are easy for me to say only because I can't imagine someone's going to debate it, a known high harm sex offender who is on immediate release that we didn't agree with, but our justice system, and that's the way the world works, and we believe there's an imminent risk in a particular area, and we had the ability to monitor that. Let's debate it, but who wants us not to flip the switch in that? And we're not looking for people, we're looking for one person, that we would have a high quality match, hopefully in our system, and we were matching that against the faces that it sees, but it dumps immediately after 14 days. That all of our systems dump that information because we have no need. It's not a need. It's not responsible to keep it any longer anyway. But the reality is, we're looking for one face for that purpose.
So on that, I'm actually going to go back on my word and pose a question that was just asked because I think it's a good kind of follow-up. So how does AI facial recognition identify someone if they don't have a criminal record? So right now, the idea in the guideline is use a criminal record database. But what if you're looking for example, that missing person? Is it consent-based?
Yes. And so we would ask that those that are reporting someone missing, a loved one, a child, that we would what images do you have? We'd look for the highest quality. We'd have a facial recognition analyst, like what's the best one that's going to get us, the most true positives. Now, on that, and I like that to talk about it, we'd be more than willing to accept a very high false positive rate. We just need to find them. Time is like, it is catastrophic, especially in our winters, for vulnerable populations. And the deputy and I have lived through the experience when we lost a member of our community. I do not want to repeat that ever again if we had the ability to find that individual.
So another thing we kind of talked about is human in the loop. And I will say, Chief, if you ever need to tap in, we have a couple experts here that can help you.
We were talking about
Just saying. And even Matt is still online. He hasn't gone to sleep yet. So, he's up here with us too. So question from the community is, what is the internal process once the software, now again, we don't use this, so hypothetically, what would be the internal process once the software flags a match? Does a human officer verify the result before an arrest warrant is considered? If the software flags a match, what human-led steps happen before the officer even makes contact with that person?
Okay, so this is all potentials. We have nothing, we have not built the policy and procedure. This is part and parcel of it to inform what we're going to do. So if I was to think what would possibly be involved is we have a hit, a possible hit. And I say a possible hit because I'm looking at the error rates and what's the dial turned up for that and what's it for. But think of this as another tool in an investigator's toolbox. So let me be clear. Let me be clear. There will always be at least, and I don't want to say one, multiple humans in the loop here. This is not a decision-making tool. It will not be used as a decision-making tool. It will help inform people making decisions. And so necessarily, I forecast a facial recognition analyst looking at it with their analysis of that. Is there a potential, high potential, passing along to the investigator to then investigate it? We live in Canada, and in this country, we are not the law. We are not the law. We are part of the justice system. Our justice system, you may think it's the worst in the world, maybe it is, but it's the best one in the going. So I will suggest to you this. We're the front end of it. So we would then follow up with our investigative tools, which would be normal practice for us to talk to people, alibi, like as you can imagine a detective would do. And then, should we believe that to be the right individual, the individual is contacted depending upon risk factors and a whole host of other things that occur. And if that individual is actually arrested, then it starts in the justice system. But I'd be remiss in saying, outside of machine learning, let's not fool ourselves. This makes mistakes. So putting humans into the system doesn't remove bias. Data is biased by the nature of who puts the data in. We all have biases. So I'm under no illusion that we're going to get this perfect system, and that's fair to say, but and simply adding people and keeping us in it, which we will always do, we still get things wrong. But I think the ask is of our community that the intention is there, and this is not a taking someone halfway across the country. Oh, we all have theories, but I'll just leave it in this country and in this province. I can appreciate that we're that front end of the justice system. It goes to the Crown and defense, and there's a healthy defense, and there's the judiciary that preside over that. That's all beyond our control, as it should be. We're just a piece of the justice system.
We really should have got a bigger mic, I think. One last question for you, and then Matt, I am going to bug you and kind of the panel because it's more of a research-based question. But in the future, where can the community find information and how transparent will BPS be about how the algorithms are being used, when these things are being used, how it's being trained?
So I can speak to a few of those things. I think as a result of looking at the research and the desire of a community, and that was the sample size was 1,000 people in the GTA, but I think we can extrapolate some things, not saying necessarily, but the more transparent we are, the better. And we had our tech panel. I think there's an expectation on this community. You'd want to know when we're using it. And I would think web access in terms of when we're using it, what was it used for? We cannot give out, we're not going to breach MFIPA privacy. We will not. But we can certainly say there's an occurrence and it was related to a high harm offender, a missing person, or missing youth, or missing like a missing vulnerable population. Like we would certainly make that as, I think, putting that on their website. But alongside, I think a great point was made on the webinar I watched was policy and procedures. What we can control, we should be transparent with. We are public safety. We police by consent in this country. It's a Peelian-based model, Sir Robert Peel out of Britain. And we should be held accountable to our use of, to the constraining of your freedom. And that should all be clear as day with our policy and procedure with respect to any technological use. That's an expectation you should have. So we would commit to that. With respect to the proprietary black box algorithms, a little more challenging, I think. And I mean, I know the various companies have white papers that you can look at their tech specs. Folks, I can't tell you how a television works, but I know when I switch the channel, I see the channel I like it works, and I'm watching a show that I want. Please don't, we will do everything we can within our control and power and expectations. I think we should have expectations of our legislative bodies and others to help us deliver public safety. But make no mistake, the tech is there. How do you not leverage tools that may be able to help bring families back together, or maybe stopping high harm offenders of very serious offenses committed in our community from doing more harm? Reducing victimization is what policing is about. Okay?
Absolutely. You can sit down now. You've been dismissed. I get my mic back. I feel powerful again. So we did get a question from the community, and I'm going to pose this, Matt, to you and kind of the panel writ large. It says, it's kind of a clarifying / asking for more information. Is the study presented by Dr. Bland showing higher true positive rates for Black people only showing true positives? What does the research show about false positives? So I guess the misidentification for racialized groups.
So we hardly had any, and that was really because it's so much rarer, we have to really push so many more people through the study to find out what whether there was differential rates. So in sort of, I don't know, 8,000 goes past the camera, we had, I think, 6 actual false positives. So we basically couldn't be conclusive about it. We would need to run the experiment perhaps 10 times the size to actually determine that. We did look at the real data from when the force was using facial recognition in the field. They scanned over, I think it was 1.3 million people's faces, and they had 1 false positive in all of that. So we're talking about something that is extremely rare in practice.
Mm-hmm. Absolutely. And we say extremely rare, but when it does happen, right, like the huge social impacts and kind of what as a community and a society are we willing to accept and digest. So thank you for that question. We're at 7:45. It's getting dark out. We're going to close it here. There are a few more questions that have come in, like I said, but we will tackle those. The Barrie Police Communications team and myself will work on getting answers for our community to those pieces. I do want to say, in terms of following next steps, we will be updating this page and this website. We're going to put in an open forum and ask, what would you like to see in policy, and the idea of having it very much a open text box chat to get that information in. We're going to think of creative ways to kind of talk about how far as a community we feel comfortable with turning the dial. We talked about sharing policy. So, as we kind of continue to work with, members who've come to these events and our community partners in these pieces, drafting up policy, and we're not going to get it right on the first time, but posting that and posting that for feedback and taking that feedback in and kind of continuously making that a live document until we as a community, I feel like, can come to a consensus on what that looks like, and continuously, thank you so much, you guys. I will say this panel, they're not only here for tonight, but the chief and I have been working with this panel quite a bit. And when we say they're the experts, they're the ones we go to because we are not the experts. And we'll continue to keep them in the loop and bug them with all of these questions because we can't all know everything. We all have our strengths. So I think, collaboration is really the key. So thank you. There's some snacks over here. We'll stay and mingle for a bit. And thank you for coming out.